Chuck, what's been eating you?
So here's a question that resonates with my, I shall say, razor sharp acumen. Why is the sky blue?
You mean that hasn't been answered since childhood?
You know what? Here's the problem. I asked once, and they were like, "Mind your business," and that was the end of it. No.
Well, you might say, "I want to become an atmospheric scientist. It is my business."
That would have
Well,
been
there you go.
That would have been a very snappy comeback for a 3-year-old. Why is this guy blue? Mind your business. It is my business. I would like to be an atmospheric scientist. So.
All right. So the answer is easy to understand. It's just not simple.
First of all, is the sky blue?
Yes.
Okay. Well, at least we got that out.
Does it look blue to you?
It does.
Fine. That's what we're about to talk about.
All right.
Okay. So here's the deal. The explanation is actually simple. It just takes a little while to explain.
Okay.
That's all.
All right.
All right.
I have time.
You have time.
I have some time.
Thank you. Thank you.
Yes, and boom.
All right. So we have an atmosphere.
Okay.
We all know this.
Yes, we do.
Okay. It's composed primarily of nitrogen.
Okay.
78% nitrogen, it's 21% oxygen, and a few percent other, carbon dioxide, this sort of thing. Mixed in there are particles of like pollen and dust and sand from sandstorms and pollution and smog. And so
Particulates.
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 Okay. Now, light comes from the sun. White light. People say the sun is yellow. It's white.
Right.
Okay.
Exactly.
You've seen the sun in the middle of the day. It's white.
It is white.
Okay. That's the proper color of the sun in the middle of the day.
Let's not get racist.
Let's.
It don't have to be the proper color.
Look, it's just a color.
It's just the color.
Damn, Chuck. Why is everything a race thing to you?
Because I live in America.
All right. So you may remember that white light is composed of colors.
Right.
Okay.
Put it through a prism.
That's how you get a rainbow.
All right.
Or you're educated, you said prism, but through a raindrop, it spreads them out into colors.
Right.
And you get the colors of the rainbow. Roy G. Biv.
Okay.
Give them to me.
Right. Red, green, blue, yellow.
Roy G. Biv, go.
Roy, red, orange, green.
Roy, yeah.
Oh, red, orange, yellow, green, blue. And then ultraviolet, but violet.
Biv.
Okay, indigo, violet.
Thank you. Red, orange, yellow, green, blue, indigo,
violet.
Okay, the 7 colors of the spectrum. Okay,
Right.
if you, the way our brain works and the sensors in your retina, okay, the rods, the
Rods and cones.
Yeah, the rods give you shades of light and intensity. The cones disentangle color.
Okay.
Okay, and you have an RGB cones.
Nice.
Okay, so we get RGB from.
Right.
You've heard that in computers and
right.
the computer screens and everything. Okay, so you are chemically, with the chemicals in your retina, splitting that red light into combinations of red, green, and blue.
Okay.
Okay, broad combinations of these 3. If you have more red than the others, what you look at is going to look more red to you.
Right.
If you have more blue than the others, it's going to look blue. Now here's what happens. White light comes down from the sun.
Is that what it does?
The particles in the atmosphere, some of them are about the same size as the wavelength of blue light.
Sweet.
All right. Now, if you have a particle and light, and there's a particle the same size as that light, it'll reflect.
That's right.
Or scatter. That's the proper word. Okay. Bounce, scatter, and so that light doesn't make it straight through. It sends in every other direction.
Oh.
So the light from the sun selectively has the blue removed on its way down to Earth's surface. And the blue scatters into the air. And you have a blue sky.
That's very romantic.
It is beautiful. Now, it's called Rayleigh scattering. A guy named Rayleigh.
Rayleigh scattering.
Rayleigh. Okay? Lord Rayleigh.
Of course, Lord Rayleigh. Indeed.
You figured this stuff out. You a lord.
Right.
All right. So here's the thing. As the sun gets lower in the atmosphere,
Right.
the path length of the light is much longer through the air. Okay, so in other words, so here's your atmosphere. If you're directly above, you're going through like this thickness. As you come down, the thickness gets more.
Right.
Okay?
Right.
Well, more atmosphere, more scattering.
Right.
The sky gets more blue. Okay? So in the daytime, it's, quote, sky blue. That's actually a pale blue.
Right, it's a very pale blue.
As you go to twilight, that sucker gets deep.
Yeah.
It gets deep blue. And so much more blue gets taken out of the sun.
I just love how violent deep blue is.
It's deep. And if you take out that much blue, the sun ain't got no blue light left at all. So what color is it going to turn?
Kind of red.
Kind of red.
Kind of red.
Kind of red, amber.
Yeah.
Okay? That's why sunsets are red.
Oh, that's
Because so much blue was taken out.
right.
That's all it has left to give you is the side of the spectrum where you have red, orange, yellow. Now, sometimes you have a very bright sunset that's not quite deep red. Aren't many particles there for that sunset. Aren't many particles.
Sweet. So that's a kind of a lighter cut, like
Yeah. So the sky wouldn't get as intensely blue when that happens.
Right.
It'll be similar to the sky blue you had earlier in the day. So that's why we have a blue sky.
Nice.
Now, it's also why you can't see stars in the daytime other than the sun.
Well, wouldn't
It's,
that...
it's, why- it's not, oh, you can't see stars in the daytime because the sun is out.
All right.
That's not why.
Because the sun is brighter than the starlight that you would otherwise see.
No, that's not why.
Well, see, that's intuitive.
No.
That's how you would think.
It's intuitive, but it's wrong. Okay? The reason why you can't see stars in the daytime is because the scattered blue light has rendered our atmosphere aglow.
Nice.
The atmosphere is glowing blue light. And that prevents you from seeing the stars behind it. If you took away the atmosphere,
You'd be able to look up and see the sun.
the sun will be there, but then you like dark adjust over here, and there's full sky, full stars right over here.
Wow.
Over there, all around.
Oh, man. You know what?
What?
If we didn't need atmosphere, I'd want to get rid of it. That kind of sucks.
Okay, so now, this is what led to the operational definition of the edge of the atmosphere.
Okay.
Okay? It's kind of operational. It is how high up in the air do you have to go before there aren't so many air molecules above you for the blue light to scatter and prevent you from seeing the night sky.
So it's really about the number of particles.
Yes.
It's not
The density of
about
particles.
the actual.
No, it's just the density of particles, wherever that happens. So we agree, just by convention, that if you go up 100 kilometers,
Okay.
converted, it gets 62 miles. 100 kilometers, that's about where the atmosphere is thinned out so that it's no longer scattering blue light. It is no longer a glow. And in broad daylight, you can see stars in the nighttime sky. So that's the operational definition of space.
The operational definition of space is 62 miles above our ground.
Earth's surface, correct.
Earth's surface, where you can just see space, basically.
Because the atmosphere that
atmosphere
remains, there's still atmosphere there, but it's not dense enough to scatter blue light and render it a glow to prevent you from seeing the night sky. Now, I'm not comfortable with that. I understand it.
Okay.
I'm not comfortable.
Now, what's your problem with that?
Because if the atmosphere were half as thick as it is,
Well, then it would be only be 30.
it would be
31 miles.
31 miles. That would be space. Well, suppose we're a tenth of it. Then it would be 3 miles. Suppose we didn't have an atmosphere. You'd be in space just standing here, sitting here like this. Should that be called space? That's what I'm saying. Our definition of space is linked to to the circumstances of our atmosphere.
That kind of makes sense. Well, no, I see what you're saying now, because I was about to say it kind of makes sense because you can't breathe in space, but you also cannot breathe at 35,000 feet.
Right. That's why airplanes have windows that don't roll down.
Right. Wouldn't that be great? Excuse me! Trying to get to Australia.
Can you tell me which way?
Hey, yeah, you want to go over here and take a left at that cloud.
And take a look before the cloud disappears.
Right,
I'm telling you where to
exactly.
turn.
Yeah, so it makes sense. I
It's
see
not about where you can breathe.
yeah, I see where your problem
It's hard
is.
enough to breathe just on a mountaintop.
Exactly.
You ever run a quarter mile on a mountaintop?
I've never run a quarter mile, period. Are you kidding me?
So now, you
So
might say,
what would your operational definition of space be if it is not indeed this particular
Either in-
atmospheric link?
thank you. If you take out the atmosphere, either you're in orbit or you're going somewhere. then you're in space.
Oh, so you're using, oh God, you are such a damn astrophysicist.
You got a problem with that?
You are using gravity as the measure of what makes space. At least you are consistent. Oh my
You got a
God,
problem with that?
that is amazing.
And that would be true no matter what atmosphere we had.
I should have known.
What? I'm just saying.
It's like,
Of course.
He's like, no, man, where does gravity fit into this?
Okay.
All right, you talking about
All right.
atmosphere.
So you know how much atmosphere that is? 62 miles. That's high up. I will show you.
All right. Oh my God, you had to break a globe to show us
I
this.
just took it on. This is like God.
that's just a holder.
This is God holding up the globe.
That's
okay?
Atlas. Okay,
That's
there we
right.
go.
Right. Okay. So I'm going to show you. Here's the United States,
Right.
and I just did some distances I know. New York to Boston.
There we are.
That's 200 miles.
I don't
Okay.
know. Go ahead.
220 miles. No, 180 miles. Okay.
right, all right.
So you take a third of that distance.
Okay.
That's 60.
Okay.
Make that go vertically up.
All right.
That's the edge of our atmosphere. 3/8 of an inch up.
3/8 of 1 inch off this is what makes it.
Is
Oh my God, we're in danger.
so
That is not cool.
Earth's atmosphere is to Earth as the skin of an apple is to an apple.
That's what I'm saying.
We don't have much air.
We are in danger.
That air is frail and fragile.
Oh my God.
And you're doing what to it?
And we're doing all kinds of nasty stuff to it. That is unbelievable. Would you eat an apple that somebody just rubbed crap all over? No. Oh, that's insane.
Oh, so I misspoke. 3/8 of an inch up, that's the altitude of the International Space Station orbiting.
Oh my God. So our atmosphere is actually
Less than
below
that.
that.
Yeah, so I'm just looking at here. There's New York and there's Boston. So you're talking a couple of millimeters, about a millimeter above 2
that's
millimeters.
terrible.
That's the thickness of the air above which we say you entered space.
Why are we not teaching this in school? I mean, seriously. If you ever want to have a true appreciation of just what a delicate balance we live in, that is it right there.
Correct.
Ugh,
Correct.
it's chilling. That's
The
really
skin of
chilling.
an apple is to an apple as the shellac on this globe is to the globe itself.
Ugh,
That is our atmosphere.
oh my God.
Dude.
Well, there you have it. We're all gonna die.
So that's why the sky is blue.
That's right.
That's why we should look after this little bit of air that we got here on the surface of the Earth.
I'm with you.
And it's why Neil thinks space should be defined by gravity, not by what the circumstances of our atmosphere happen to be.
There you go. You know, I'm gonna agree with all three, man. Yeah, and not because you're my boss.
That's a Star Talk info bit. As always, keep looking up.